Our last two functions are the reciprocal functions, secant and cosecant. So let's look at secant first. Secant I'm going to define a couple of different ways. One, we know that on the unit circle it's 1 over the x value. So looking at here we have an x value of 1, here we have an x value of 0, -1, 0. Another way of looking at it is that it's the reciprocal of cosine. So we can use our cosine values also to help us in graphing this function. Looking at our cosine graph, this is our y equals cosine graph. Anywhere that cosine is 0, secant is going to be undefined. So at pi over 2, negative pi over 2, negative 3 pi over 2, positive pi over 2, positive 3 pi over 2, any of these places where cosine is 0, secant is going to be undefined, and therefore it's going to have asymptotes at these places, vertical asymptotes. Alright, the nature of the reciprocal is that anywhere that cosine is positive 1, the reciprocal of positive 1 is also positive 1. This is actually going to be the only points where cosine and secant are the same, and the same for -1, where cosine is -1, secant is also going to be -1. Now as we get closer to a vertical asymptote, our function is either going to go off to positive or negative infinity. And one way we can find this is, let's look at where cosine is 1/2 or -1/2, because those are good points to help us. They're easy to calculate the reciprocal, because the reciprocal of 1/2 is 2. So looking at cosine, cosine is x 1/2 at pi over 3. And our x value is negative 1/2 at 2 pi over 3. And it's also positive 1/2 at negative pi over 3. And it's also negative 1/2 at positive, or at negative 2 pi over 3. So at this point, at positive pi over 3, somewhere in this area, cosine is 1/2, so that means secant would be 2. And similarly, at around negative pi over 3, cosine is 1/2, so secant would be 2. This just gives us a few points to look for when we're trying to graph our secant function. Similarly, we have values for -2, and we can finish graphing out our secant function. Key points to remember is secant is undefined anywhere that cosine is 0. So if that's at pi over 2, negative pi over 2, 3 pi over 2, and so forth. It's also positive 1 anywhere cosine is positive 1. That's at 0, 2 pi, 4 pi, even pi's. And it is -1 anywhere cosine is -1. That's going to be at pi, negative pi, any of the odd pi's. We have a similar relationship between cosecant and sine. Cosecant is 1 over y, the reciprocal of y, if we're defining it from the unit circle. It's also the reciprocal of sine. So anywhere that sine is 0, we can tell that cosecant will be undefined. And these are going to be our vertical asymptotes for the cosecant function. So if we look at where sine is 0 at the multiples of pi, these are going to be asymptotes, vertical asymptotes, where the cosecant function is not defined. And where sine is positive 1, the reciprocal of 1 is 1, and the reciprocal of -1 is -1, so these are going to be the points that sine and cosecant have in common, their graphs. And if we look at where sine is equal to 1/2, that's where our y value is 1/2. Those are the pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. At these points where the sine function is 1/2, that's where the cosecant function will be 2. Will be the number 2, not 2 also. So where sine is 1/2, cosecant will be 2. And that gives us our cosecant graph. Again, the key points to look for: where is cosecant the same as sine? That would be at the pi over 2's, negative 3 pi over 2, pi over 2, negative pi over 2, 3 pi over 2, so forth. And where is cosecant undefined? That would be anywhere that sine is 0, and that's going to be your multiples of pi.